Okay, in example 418 is where we really see the payoff for learning the rules of how to expand and condense logarithmic expressions, because it's going to make taking the derivative of some of these functions much, much simpler. So in this first example, we have the natural log of the square root of x squared plus 1, which you should remember is equal to the natural log of x squared plus 1 raised to the 1/2 power. So square root and raising to the 1/2 power is the same thing, right? And now, if you were to take the derivative of this, you'd have to use chain rule twice. But if you use the properties of logarithms, you can write this as 1/2 times the natural log of x squared plus 1. And now it's much simpler to take the derivative of that. You just take the 1/2 goes out front, and then the derivative of ln of x squared plus 1 is 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. And so that becomes just x over x squared plus 1. This 2x and that 2 canceled. So we only had to use chain rule once, and you can almost do that in your head because you know it's just going to be 1 over u times du dx. Okay. Now, that was a little bit simpler, but the second one, g of x, is so much simpler if you use properties of logarithms. So I'm going to write this as g of x is equal to natural log of x squared plus natural log of the quantity x cubed plus 2x raised to the second power, or squared. And then you use properties of the power property to make this 2 ln of x plus 2 times ln of x cubed plus 2x. Okay, and now we're ready to take the derivative. Okay, so originally we would have had to have taken a chain rule inside of a product rule inside of the derivative of a log, and it would have been really messy. But if you expand things first, this becomes so much simpler. G prime of x is just 2 over x, and that's 2 times the derivative of ln of x, which is 1 over x. And then that's plus 2 times 1 over x cubed plus 2x, so that's the 1 over u part, and then du dx in this case would be 3x squared plus 2. That's the derivative of the x cubed plus 2x. And now I should distribute this 2 into that sum. So I end up with 2 over x plus 6x squared plus 4 over x cubed plus 2x. And so I was just distributing the 2 into the 3x squared plus 2. And that is my final answer for g prime of x. Okay, and I want to reiterate, that is so much simpler than trying to take the derivative of ln of x squared times x cubed plus 2x squared, because this would require a chain rule, that would require a chain rule, and you would have to have a chain rule because of the ln of u part, right? So there'd be 3 chain rules and a product rule, and it would just be really, really messy.